welcome back to my channel. In this video we'll continue with the solution to question 2, so stay with me as I take you through the solution. The first part of the question reads, if the limit as x approaches 2 of 3x squared plus ax plus a plus 3 all over x squared minus x minus 2 exists. I find the value of a, of the real number a, and then I compute the above limit. So we are going to compute the limit as x approaches. Let's say this function is f of x, so the limit as x approaches f of x. Okay, so this is the first task we've been given, so let's see how we will handle this problem. So let me open this. So the problem is what? Limit as x approaches 2 of what? So let me first define this. Let f of x equal to, I don't want to be repeating this this function, that's why I'm just representing it by what? F of x. So 3x squared plus what? Ax plus a plus 3 all over x squared minus x minus 2. So that is it, and I can close it now and close this part. Okay, so limit as, so this means that limit as x approaches 2 of f of x will be equal to the limit as x approaches 2 of 3x squared plus ax plus a plus 3 all over, let's factorize this guy. We have x squared minus x plus x minus 2x minus 2 to represent this guy, so we use x minus 2x to represent the negative x. So this means that the limit as x approaches 2 of f of x will be equal to the limit as x approaches 2 of 3x squared plus ax plus a plus 3 all over x multiplying x minus 1, x plus 1 minus 2 multiplying x plus 1. So this will lead us to the limit as x approaches 2 of 3x squared plus ax plus a plus 3 all over x plus 1 multiplying x minus 2. Okay, so we know that if we substitute 2 into this, into the denominator will become 0. That means that f of x itself does not exist. F of x does not exist. But since the question is suggesting that the limits exist, that means that the denominator, sorry, the numerator has a factor x minus 2 multiplying some y. So this 3x squared plus ax plus 3. So the 3x squared plus ax plus a plus 3 is equal to some x minus 2 multiplying another factor over what? This x minus 2. So this 3x squared is equal to something like this. Let me cancel this part because I'm only quoting 3x squared. So that means that our limit, the limit as x, so if that is that, we know that it is something like this for sure, because since the limit exists, then we have something like this. So the limit as x approaches 2 of f of x will be equal to this x minus 2 multiplying our y over what? X plus 1 x minus 2. So this will deal with this, leaving y over x plus 1. So in this case, the limit as x approaches 2 will not be what? Undefined. It will be defined, and the limit will exist. If not, if there's no common factor, if there's no factor in the numerator for which the x minus 2 at the denominator will cancel, then the limit doesn't exist. But the question suggested that if this limit exists, we should find all that we should find, all we are asked to find. So let's see. After dividing, let's divide. So if the limit exists, so let's do it this way. If the limit exists, then this x minus 2 will be what? Should be what? A factor of 3x squared plus ax plus all those guys are the numerator. So if the limit exists, the limit can only exist if x minus 2 is what? A factor of what? The numerator. So the limit can only exist if and only if x minus 2 is a factor of 3x squared plus ax plus a plus 3. Implies 3x squared plus ax plus 3 over x minus 2 is equal to, so if we use long division, so if we are using long division, let me bring the x minus 2 here, x minus 2 here, so that okay, I can even leave it there. So I have my divisor and my dividend, x squared plus ax plus a plus 3. I missed out the a here, so let me bring it back. So here, so 3x squared, so we know that if it is a factor, it can only be a factor if it divides this without any remainder. So we are dividing. So 3x squared divided by x, we have x, 3x there. So 3x times this, we have 3x squared minus what? 6x. So this minus that, we have 0. So ax minus 6x plus 6x, so it becomes ax plus 6x. So plus a plus 3. So we should have done ax minus 6x. So ax minus negative 6x gives us what? Ax plus 6x. And this, the constant a plus 3 minus the constant here is 0, so a plus 3 minus that becomes a plus 3. Okay, so here this guy is the same as a plus 3, sorry, a plus 6 multiplying x. So if we divide this by the highest power, which is x here, by x here, we have this to what? A plus 6. So a plus 6 times x will give us ax plus 6x. A plus 6 times negative 2 will give us, so negative 2 times a, we have minus negative 2 times a will give us, so minus 2a. So negative 2 times a have minus 2a. Negative 2 times 6, negative 2 times 6 will give us negative 2 times 6 will give us minus what? 12. And this will give you 0. So we have here a minus this will give you 3a plus 3 minus negative 12 will give you 15. And we know that this is the final part, and this part should be equal to what? 0 if and only if the x minus 2 is what? A factor. If and only if x minus 2 is a factor, we have 3a plus 15. So we can, it should be 0. The 3a plus 15 should be 0. So we can easily find a here. So our a is equal to what? Negative 5 by if we divide through by what? Positive 3. So since we've assumed that it's a factor, that means that the remainder should be equal to what? 0. And this and then since we now have the value for a, so now we have the value for a. The value for a is here. A is negative 5. So now we also know that our 3x, our quotient, let me go to the quotient. The quotient, this is now, a is now negative 5, so negative 5 plus 6 will give you positive 1, so we have 3x plus 1 here as the quotient. Okay, so now we can now say that our 3x square, so if we divide 3x square plus the ax, now we have a to what? Negative 5x, so let me remove the plus, so minus 5x. So now we just have the value for this. We can just continue, we can just go back to the question and continue instead of wasting time doing all this stuff. So let me go back to where is the question. Okay, so now we have the value for a is negative 5. So here wherever I see a, so I can put back the 5. So I'll have my limit as x approaches 2 of what? My 3x square plus what? The ax. Ax is now what? Ax is the same as what? Minus 5x. So a is now negative 5. So minus 5x plus a. So minus 5. So plus a will become what? Minus 5 plus 3. So minus 5 plus 3 will give you what? Minus 2. So minus 2 all over. We know that this is x plus, is it x plus 1, x minus 3, x minus 2, something like this. Yes, so that is it. And this will lead us to, if we factorize this guy, we get 3x squared minus 5x minus this. So we can represent the negative 5x by 3x squared minus 3x minus 2x So this no, this will not give us the result we want, so we can use minus 6x plus x minus what? Minus 2 to represent this. So we can now factor out 3x here, so 3x out, we have x minus 2 plus 1 out. We can factor out 1 here and factor out 1 there. We have what? X minus 2 all over what? X plus 1 x minus 2. So from here our limit, so this is still our limit as x approaches 2. This is still the limit as x approaches 2. So it implies our limit as what? X approaches 2 will become 3. Sorry, we can factor out x minus 2, or we can just say 3x plus 1 multiplying x minus 2 all over x plus 1 x minus 2. We count all this and remove this end brackets, and with this you see that we now have that guy x minus 2 at the top and x minus 2 at the bottom, so they will cancel out. So our limit as x approaches 2 of 3x plus 1 over what? X plus 1 will be what? 3 multiplying 2 plus 1 over what? 2 plus 1. And this will be 3 multiplying 2 will be 7 7. So this is 6 plus 1 is 7 over what? 3, and this is what? The limit we were asked to what? Compute. So this is the what? The second part of the question 2a. Let's see what the third part says. So now cancel this. We have an answer for this. We had a to be -5, and we had the limit to be what? 7 on 3. So now let's look at this guy finally, and the question is given that y equal to the sine inverse of x all square, show that 1 minus x square d square y dx square minus x dy dx is equal to 2. So this is what we are coming to show. So now let's open our book, our workbook again, and let's scroll. So let me copy the function y is equal to sine inverse of x all square, like this. And we're going to show that 1 minus x square d square y over the x square minus x dy dx equal to 2. So first what we need to do is to what? Find dy dx from this. So our derivative dy dx, so let me solve it this way. So d dx of y will be equal to d dx of what we have here, sine inverse of x all square. So my dy dx will be equal to, so first I differentiate this function, so it will become 2 multiplying the derivative of the inner function, so d dx of sine inverse of x multiplying the function itself, which is sine. So we are just applying, so sine inverse of x all to the power 2 minus 1 all to the power 2, so we subtract 1 from the function. So the chain rule and what composite functions, that's what we are just applying here, the differential of that. So we have dy dx easily here, so 2. You see from our past video we proved this, we prove it. So let me just send you, I haven't deleted anything, I have the proof here, and it is here. So the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. So I only prove it so that we can use it to solve this question. And I don't want to be solving the question, it will be like, where do we get this this square root of 1 minus x squared here? I don't want it to be like that. That's why I just show it, and you can now show it yourself and you have understood it perfectly. So the derivative of this d dx of sine inverse of x is what we have proved to be what? We have proven to be 1 over what? The square root of 1 minus x squared. So this multiplying a sine inverse of what? X. Because 2 minus 1 is just to the power 1. So sine inverse of x all to the power 1 remains the same thing. Okay, so the derivative, our derivative dy dx becomes what? 2 sine inverse of x all over the square root of 1 minus x squared. So this is it. This is dy dx. Let's see our answer once again. There's d square y dx square in the answer. That's the highest derivative there. So let's differentiate this our function further. So let's note this down. So maybe we can call this equation 1. So let's differentiate further. We might need this guy as we continue with our solution. So we differentiate further. So the derivative d dx of dy dx will be equal to the derivative, so d dx of what? 2 sine inverse of x over the square root of 1 minus x squared. And here we can apply the product rule, sorry, the quotient rule is dividing, so we can apply the quotient rule. So d dx of dy dx gives us d square y over dx square, and this is equal to d dx of this means that we first of all So the square y over dx square will be what? First of all, differentiate the numerator, so 2 ddx of what? The numerator, which is sine inverse of x, multiplying our denominator, the square root of 1 minus x squared. So this minus, so this is the quotient rule, so we subtract the derivative of this, so ddx of the square root of 1 minus x squared, this multiplying 2 sine inverse of x all over let me reduce this. So all over our denominator square, 1 minus x square, all to the power 2. So this is the what? The product rule. If I have v over u, so we have, if I have u over v, this is the traditional way. So I have the derivative of u, let's say u prime, multiplying v plus, minus the derivative of v, so v prime multiplying u all over v square. Okay, so this is the what? The product rule. Okay, so let's now simplify this. So should I do it by parts? Let me do it by parts. So first 2 dx of sine inverse. So let me just note this. I'll just do it partly and then bring it and substitute the values. Sine inverse of x is equal to, so 2 multiplying, we already know the derivative of this to be what? 1 over the square root of what? 1 minus x square, 1 minus x square. This is called 2 over what? The square root of 1 minus x square. So this is part 1. Part 2, which part again should we consider? Let's look at this part. Let's look at the minus part. So d dx, so d dx of this, the square root of 1 minus x square is equal to, so this is the same as d dx, the derivative of 1 minus x square all to the power half, and the derivative is equal to what? Half multiplying the derivative of whatever is in the circle, whatever is within the parenthesis, which is negative 2x. So if we differentiate whatever we have, the differential of 1 is 0 minus the differential of x squared is what? 2x. So 0 minus 2x is what? Negative 2x. So this multiplying, so we multiply this by what? 1 minus x squared all to the power half minus 1. We subtract 1. Whenever we differentiate, we subtract 1. And this will give us what? This will give us 1 over 2 times negative 2 will give us minus x multiplying 1 minus x squared all to the power negative half. And this, by applying the roots of indices, we can write it as negative x all over the inverse rule. We know that if I have a to the power negative n is equal to what? 1 over a to the power positive n. So this will give me 1 minus x squared all to the power positive half, and this is the same as minus x all over the square root of 1 minus x squared. And I think those are the big guys we need to tackle there, and the rest are easy to work with. Yes, the rest are easy to work with. So let's bring it here and let's substitute our answer there. So now let's go back. Let's quote our d square y over dx square is equal to 2 multiplying the x, so the x, so we just reduce that guy to 2. So now we know that this guy, or then this part of the numerator, is now what? 2 over 1 minus x squared. So let's write it there. Let's write it here. So we write 2 over 1 minus x squared. Is the root there? I believe the root is there. Let me see. We have the root. Yes, it's inside the square root. Okay, so now let's go back to the second part. So minus, so let me bring my minus there. Minus so dx of the square root of 1 minus x squared, and we have the answer. The answer is what? Is here, negative x over the square root. So we have minus negative x. So let me just change this to plus, then positive x. So plus x over the square root of 1 minus x squared. Now we have this 2. So this is multiplying what? Let's go back and see. So it's multiplying 2 sine inverse of what? X. So multiplying 2 sine inverse of x. Okay, so we have this. So this all over the square root of the square root of the square root of 1 minus x squared. This will deal with this. So the square will deal with the root. So we now have 1 minus x squared. So we substitute it here. Okay, so we substitute it here. So we have 1 minus what? X squared. Okay, we are doing something and we will get somewhere where we wanted. So now we have this, and this is fine. Let's see. Let's see something. Let's go back to our equation and see what we need to do to bring the, because there's in the answer we need in the answer we need dy dx. We need dy dx. So if we need dy dx, let's see, maybe something in our dy dx, something in our d square dy, d square y dx square is in this thing. We can substitute something from dy dx to the d square y dx square. So let's see, this is our dy dx. Dy dx is here. It's here, and look at it. Is 2 sine inverse of x all over root 1 minus x squared. So now let's go back. Let me close this. 2, let's check it again. 2 sine inverse, so dy dx equal to 2 sine inverse of x all over root of 1 minus x squared. 2 sine inverse of x all over this. So let's just rewrite it. So we know that our d square y over dx square is equal to 2 over the square root of 1 minus x square plus, so I can have it this way, 2 sine inverse of x all over the square root of 1 minus x square, multiplying the numerator x here, so multiplying x. So I just bring this and you know how to do it, so no problem. Okay, so I now have this. Oh, sorry, I said something to show to the solution. So I now have this all over my 1 minus x square. I now have this. Okay, but from equation 1, so from our initial equation, we have dy dx to be equal to 2 sine inverse of x all over the square root of 1 minus x square. We have this from our equation, the first equation. Let's check it once again. So once again, it's here. Here, dy dx is equal to what? 2 sine inverse of x all over the square root of 1 minus x square. So wherever we see 2 sine inverse of x all over the square root of 1 minus x square, we represent it by what? We represent it by dy dx. If we even want, we can even multiply the denominator too. We can multiply through by by 1 minus x square, so that we will stop dividing by the 1 minus x square. So we multiply both sides by 1 minus x square. So we have 1 minus x square multiplying the d square y over dx square to be equal to 2 over the square root of, so 2 over the square root of 1 minus x square plus this 2 sine inverse of x all over the square root of 1 minus x square will now be represented by dy dx, so all over dy dx multiplying x. So now we will have this now